All right, so in 3.4 and 3.5, we're looking at graphs of absolute value. And so when we want to graph this function, we have to remember that absolute value just measures a number's distance from 0. And so for the parent function, just absolute value of x, if I take the absolute value of 1, I would get a distance of 1. But if I take the absolute value of -1, I would also have a distance of 1. If we take the absolute value of 0, of course that would be a distance of 0. And so when we're graphing this, we have the point 0, 0, 1, 1, -1, +1. And so because when you take the absolute value of a negative number, it becomes positive, so the absolute value of -2 would be +2, absolute value of -3 would be +3. It makes this V shape. And so all absolute value functions have this V shape. And so we can actually do some transformations. We can move it left, move it right, we can stretch it, we can compress it. And so the standard form of an absolute value has this notation right here. And so this minus h is how far the function moves left or right. And so if you see a minus, it's kind of opposite of what you would expect. It moves right h units, and then the plus k outside the bars means it's moving up k. And then this a value is how much it's been vertically stretched or vertically compressed. And so vertically stretched would look really narrow if you think of stretching a rubber band, whereas vertical compression would look super wide, be shorter, and so wider. It also tells us if it's reflection. And so if you have an a value that's negative, that would just mean your absolute value is upside down. It's reflected over the x-axis. And so using this information, we can graph the function. There is what we call the vertex in the middle is our critical point. And so if it's been moved right h, usually it starts at 0, 0. If it's been moved right h, this critical point or vertex is going to move to the point hk. And then this a value tells us the slope of the graph, the lines, we call them the arms or the branches, and it also tells you whether it's opening up or down. Like I said, if a is negative, it's going to open down. And so looking at this first example, we have a negative, and that's the only thing that's different from our parent function. And so the parent function opens up. It has a critical point of 0, 0, and it has a slope of up 1 over 1 for each of the branches. And so you can look at it as a negative slope as well. You're going to have it on each side. So slope is 1. Okay, and so sometimes we say slopes because technically it's positive, negative 1. And so if you want to put the positive, negative in front of it, you're going to have that for every absolute value. And so in this case, negative absolute value of x, the critical point or vertex is still going to be 0, 0. And then the slopes are still going to be 1. There's no number here. If there was like a 2, the slope would change. There's just a negative sign. And so that negative sign just means it's opening down. And so we can graph this by starting at the critical point 0, 0. And then remembering it's opening down, we're going to have a slope of 1 for each of the branch. And so just down 1 over 1, down 1 over 1 on each side of our vertex. Okay, over here, I see this function has been moved right 1, there's a minus 1, and then up 2. Remember, minus moves you right, and so that puts my critical point at positive 1, positive 2. You take the opposite of what's with x. And so if you see a negative 1 here, you're going to have a 1 for your x coordinate. And then the y would just be exactly what you see. I treat the absolute value bars kind of like the crazy house. Everything's backwards and crazy inside a crazy house, but normal outside the house. There's no vertical stretch or vertical compression, and so the slope is still 1. There's no negative sign, so it's still opening up. So we're still going to have very similar to the parent function, just moved right 1 up 2. And so there's our new critical point at 1, 2. And then still opening up, still have a slope of 1 on each side. Over here, we still have a right 1 up 2 situation. And so the critical point would once again be 1, 2, because we're looking at the negative 1 inside and then the positive 2 outside. And then the slope this time changed to a 1/2. Okay, so you use that scale factor as your slope. And then there's no negative, so it's still opening up. And so we'll start at the critical point 1, 2. And then this time our slope is up 1 over 2. Up 1 over 2. And so you can see that's our compression by 1/2. It's a wider V because of that new slope. The smaller the slope, the wider the V. Okay, down here, I'm seeing a +3 inside and then a minus or +1 outside. And so this function actually moves left 3, but still up 1. And so our critical point would be -3, +1. You always take the opposite of what's with x to be your x coordinate, and then you take the number outside the bars to be your y coordinate. Don't change the sign of the y value. And then our slope, we're just looking at the 2, not the negative, and so the slopes would be 2 on each side, and then this negative outside means it's opening down. Ignore the negative when you're thinking of slope because you'll have the positive and negative. And so we'll graph the critical point at -3, +1. And then for the slopes, we're going to go down because of the negative. So down 2 units over 1. Down 2 units over 1. Down 2 over 1. Just like with lines, when you're looking at the slope, if it's a whole number, the bottom number is 1. So when we were doing a slope of 1, it was up 1 over 1. This 2 is technically 2 over 1. So that's why the rise is 2 and the run is 1 on each side. So 2, 1, 2, 1. Right over here, we have a left 2 and down 1. And so our critical point or our vertex is -2, -1. Once again, taking the opposite of what's with x to be our x, and then taking the y coordinate as is. Our slope this time is 3. And because there's no negative, it's still opening up. And so we'll graph that critical point at -2, -1. It's opening up and our slope is 3. If you want to rewrite that as 3 over 1, our rise is 3. Our run is 1 on each side of the critical point. So rise 3, run 1. Rise 3, run 1 on each side. Right, and so that's how we would graph from an equation. We can also do this situation in reverse by analyzing the picture and looking at the slope and looking at whether it's opening up or down. Looking at number 1, this graph is opening up. And then if we try to find the slope, we need some good points. So I always use the critical point and then start plotting good whole number points. And so it looks like this function is going up 2 over 1, up 2 over 1 on each side. And then the corner point, critical point, vertex, whatever we're calling it, is usually at 0, 0, but this one has been moved down 4 to 0, negative 4. And so because we have a down 4 and a slope of 2, we can write our equation with a 2 in front of the bars. And then because it didn't move left or right, the x-coordinate is 0, we're just going to have an x all by itself inside the bars, and then a minus 4 outside the bars to account for the down 4. This down 4 puts a minus 4 here. And then when you have a 0, you're going to have x all by himself. All right, this next function opens up, so no negative. And then our corner point, critical point, vertex is negative 3, negative 4. And the slopes of the sides, let's put some more points on here. Looks like we're just going up 1 over 1, up 1 over 1 on each side. And so when we're writing the equation, we don't have to write a number in front of the bars. If the slope is just 1, we can just leave that 1 invisible. And so to get the x-coordinate of negative 3, we're going to have a plus 3 inside with x. Remember, it's always opposite. And then we're going to have a minus 4 outside the bars for our y-coordinate. Okay, and then this last one is opening down. We finally have a negative. Okay, and then the critical point or vertex is at 0, 4. And then the slopes of the sides, we have some good points here. And so it looks like the rise is 2 and the run is 1, down 2 over 1. And so this down means we're going to have a negative in front of the bars as well as the 2 for the slope. The x-coordinate is 0, so we have x all by himself inside the bars. And then we have a plus 4 for the y-coordinate of the critical point.